Okay, so now we're going to talk about cross product. Cross product is a little bit harder to deal with. It's a little bit harder to understand conceptually what's going on as well. Basic idea, okay, of a cross product, it gives you a line, okay, another vector actually, gives you another vector that is perpendicular to the original two vectors. Okay, that's one aspect of it. Okay. The other thing is, really what you're going to do is take a look at when you multiply two vectors. We used cosine in the previous example. Now we're going to take a look at sine. Okay, and this is a case where magnitude angle is definitely the way to go if you have that opportunity. Okay, the cross product, and this is what's called the vector product. So this is cross product or vector product. What this is, okay, mathematically speaking, okay, if I take two vectors and I cross them, okay, I get A, B, sine theta. So it's the magnitude of A times the magnitude of B times the sine of the angle between them. This is pretty straightforward to do if you have magnitude angle formation. IJK, which you often have, is not so simple to go through. Yeah, you wind up going into a matrix. I'm going to give you a shortcut and not really go through the whole matrix situation. But if you think back, okay, we talked about torque. And what we said was that I gave you an equation last year. Torque was R, okay, the distance. I think I used D, so I'll use D. The distance, F times the sine of the angle between them. Okay? Now, so torque, really, we're going to use what's called a cross product. Right? We're going to get into torque a whole lot more when we get to that unit. We're going to get into it a whole lot more than we got last year. We only did where the torque equaled 0. The sum of all torques equaled 0. But really what it was, the torque was a cross product, okay? Because it introduces sine. And what you get out here is actually a vector. And we never talked about what the direction of the torque was. We said that it twisted one way or the other, which was important, but that's usually more correctly called a moment. Torque, really, what it gives you is a vector in a particular direction. And that direction is the axis through which the object is rotating, okay? So if I had something like this, okay, where I had a fixed pin here with a long arm, okay, and I applied a force in this direction. Okay, this would be my distance D. There's my force over here, okay? This would start rotating about this direction, okay? Now, the key is that this rotates, and we use a right-hand rule from E&M last year, okay? Rolls about, and we've got the vector over which this rotates. Okay, if this is your z-axis here, okay, it's going to rotate about the z-axis. And so that would be the vector that you would get out. Okay, this would be the torque. This would be your torque vector, and it goes about z-axis. Okay, and it's hard to do three-dimensionally. But, so we've done this before, we just didn't call it a cross product. So now, in magnitude angle formation, that's pretty easy. When we start doing IJK notation and unit vector notation, it's not so easy. So, but we do get situations like that. So let's just say I have vector A is equal to AX I hat plus AY J hat plus AZ K hat. And I have vector B, that's bx I hat plus by j hat plus bz k hat. We want to take the dot product of these two when they're in IJK notation. So now I'm going to show you a shortcut, and it's going to give you a general equation. Don't worry about the general equation, just use the shortcut. Okay? The way that I set this up, okay, I say, all right, if I want to do A cross B, so A cross B, I'm going to write I, J, K, and write in what my components are. I'm going to write in AX, AY, AZ, BX, Y, BZ. I'm going to put a little line here. I'm going to rewrite I and J. Say, oh, what about K? Well, we don't need it, so we don't do it. So it's AX, AY, BX, AY. Let me get that. So now, there's different equations. I'm not very good at memorizing things. Right? I'm going to go like this. This goes AY plus BZ I hat. This here goes AZ plus BX J hat plus AX BY K hat. Now, that's what you get when you go this direction. When you go the other direction, okay, you use negatives. So this becomes, and this is a positive, negative AX BZ J hat, negative AZBY I hat, negative AY BX K hat. And the reason why I don't do all the memorized ways of doing this, I always forget which way goes which and everything like that. I can remember that I go like this, and they're all positive, and I go like this, and they're all negative. That's easy. So when you add all this together, general form, I guess I'll give it to you. A cross B is equal to I hats AY plus B, AY, it's not plus, it's just times, sorry. Right here, I put a plus sign here, it shouldn't be a plus sign, it's just AY times BZ. AY BZ minus AZ BY I hat plus, I have to carry it over to the next line. The J hat is going to be AZBX, AZBX minus J hat over here, AXBZ. So you're just going to flip the subscripts here. Plus AXBY minus AYBX J hat plus K hat. Okay? So that's what the general form looks like. All right? Let's take a look. Let's take a look now at a specific example. A little bit easier. Specific examples are much easier to deal with than that general equation. That's just a bear. So now, A is equal to 3I minus 4J plus 12K. B hat is equal to negative 2I plus 6J. no K. Okay? That's very important. So now, A cross B is equal to I, J, K, I, J. 3, negative 4, 12. 3, negative 4, 12. 3, negative 4. Negative 2, 6, 0. Negative 2, 6, 0. Negative 2, 6. So now, I do it this way. That gives me 0. This gives me negative 24 j hat plus 18 k hat. This is negative because, not because it's negative going in that direction, but because it's 12 times 8, negative 2. Going this way, get 0. Okay, this is going to be negative 72 I hat. Negative times a negative again, so that's negative 8 k hat. So when I put this together, okay, I've got negative, so A cross B is equal to negative 72 I hat minus 24 j hat plus 10 k hat. Now, what I want you to do for me, I want you to do by yourself B cross A. How does A cross B compare to B cross A? I want you to do that right now. Hit pause. Okay, when you do that, you should find that B cross A is equal to 72 I hat plus 24 j hat minus 10 k hat. In other words, A cross B is equal to negative B cross A. You could do the general thing and prove it in general, but a specific example kind of shows it relatively nicely here. Okay, so order matters when you're doing cross product. A cross B is equal to negative B cross A. If you reverse order, you reverse sign. Okay. All right. I want to go over one example. I'm going to give you two vectors and have you do a bunch of things with it. There's one other thing that we're going to learn along with it. So that should take care of most of what is in chapter 3 after I do this. There's some specific examples, and you guys just need to go ahead and do the problems. But I'm going to give you a problem that's very similar to what will be on your test. Okay. So now, let's say, and this is going to be the only problem-solving portion. We've done a bunch of problems. This is really just like a math. This is just kind of adding to your math toolkit. The physics in this chapter are not all that deep. This is just giving you. This is more just math. So I don't want to get caught up in problem solving on math problems. We're going to see how we can apply these more when we get into the units more. Okay, so now I'm just going to say A is equal to 4 I hat plus 6 j hat minus 20 k hat. I'm going to say that B is equal to negative 2 I hat plus 2 j hat plus 4 k hat. Okay. Now, bunch of things that we're going to do. I'm going to say, well, I'll just put them over here. A, I want to know what A plus B is. It's pretty straightforward. I want to know what A dot B is. And what A cross B is. Okay. I'm going to do all those. I also want to know what 3A plus minus 2b is. I want to know what the y component do this 2a cross 4b. I want to know what the y component is. Okay, so we're going to do these 5 parts here. Okay, we're going to find the basics here. We're going to subtract here with and put that scalar out front. We're going to figure out how to do that. It's not very hard. Then we're going to multiply a scalar out front here, figure out what the y component of a cross product is. Okay, so let's go ahead and do that. Oh, and part F. Hopefully this still shows up. Angle between A and B. So 6 different parts. Okay. Once we do this, we'll be done with chapter 3. So now, A plus B. A plus B. Okay, I'm just going to take the x components, add it. 2i hat. Add the y components. Add the z components. And there we go. That's part A. Part B. So now, remember, dot product is a vector product. Excuse me, dot product is a scalar product. Dot product is a scalar product. So I don't put the vector here. I get 4 times the negative 2, which is negative 8. Six times 2 is 12. Negative 20 times 4 is negative 8. So A dot B is equal to 4 minus 80, which is negative 76. C, I want to do A cross B. Okay, so now I, J, K. Cross product is not, I always hated doing cross product. Just, even with the shortcut, it's not a shortcut. 4, 6, negative 20, 4, 6. Negative 2, 2, 4, negative 2, 2, 4, negative 2, 2. Okay. 24i hat plus 40j hat plus 8k. This is positive. So I come back this way. Negative 16j hat. This is negative 40, but negative again. It's positive 40 I hat. It's negative, negative 12, but negative again makes it positive 12k hat. So now, I add these together. 24i and 40i. 24i and 40i. That's 64i hat. So A cross B is equal to 64i hat. My J, let's see, I'm just going to cross these out so I can see them. J's, I've got negative 16 and 40, so that's 24j hat. K's, 20k. Okay, so that's your A cross B, that's C done. Part D. Now, 3A minus 2 minus 2B, what, okay, I haven't done anything where I put something out front. So now, 3 times A, all I'm going to do is just take all these components and multiply by 3. 12I hat plus 18J hat minus 60K hat 2B is equal to negative 2I hat, negative 4I hat plus 4J hat plus 8K hat. So 3A minus 2B. So now 3A minus 2B is equal to 12 minus a negative 4. So that's going to be 16I hat. 18 minus 4, 14J hat. Negative 60 minus 8, minus 68K hat. Okay, so that's part D done. E, 2A cross 4B. Really, I did this? Okay, so now 2A is equal to 8I hat plus 12J hat minus 40K. 2A cross 4B. Negative 8I hat plus 8J hat plus 16K hat. And I wanted the y component of 2A cross 4B. So now, I, J, K, I, J, 8, 12, negative 40, 8, 12, negative 40, 8, 12, negative 8, 8, 16, negative 8, 8. Okay, so now the y component is telling me that I want the j hats. So the i's, I don't care about I care about j. So this is the one that I'm going to worry about here, this right here. So I got, I have negative 8 times negative 4, I have positive 32 j hat. Don't worry about the k. Coming back this way, I care about this one. So I have 3264 negative 128 j hat plus 32. So yeah, again, the i's I don't care about, k's I don't care about. So what I have here is that for part E, my answer is going to be 32. Negative, let's write it out, 2A cross 4B y component is equal to negative 96. I don't need the j hat technically at that point. Negative 96. Because the y component tells me that I'm looking for j hat. But if I'm looking for a component, the component is not a vector in and of itself. Okay, F. Angle between A and B. Now, here's the thing. I can use cross product to find the angle between two vectors. I don't want to do that. I don't want to have to go through solving for the cross product yet. Okay. And of course, I erased the answer for what A dot B was. Okay, so now, part F. I wish I hadn't erased B here, but I can get it really quickly. The angle between them, I'm going to use that A dot B is equal to A, B cos theta. So A dot B, we've already done that. I'll just do this. Negative 8 plus 12 is 4. Minus 80 is negative 76. Okay. is negative 76. So now, A, magnitude of A, this is going to be square root of 4 squared plus 6 squared plus 20 squared. So this is the square root of, this is 20, let's see, 36, 16, 52. 36, 16, 52. 452. Magnitude of B is square root of 2 squared plus 2 squared plus 4 squared. So this is the square root of 4, 8, 24. So now, I know that, I'm going to go towards the bottom again. So now I'm going to use this up here. A dot B is negative 76 is equal to A, which is square root of 452 times, and I'm just going to put this on the square root too, 24. Okay, this is times cosine theta. So theta is equal to the inverse cosine of negative 76 all over the square root of 452 times 24. So theta is equal to second cosine 137 degrees. And we're done. Okay, so that's chapter 3. I'll be back next week to get up chapter 4. I'll probably have these 3 lectures up on the web by Friday or Saturday. All right.